start recording. All right, so sorry, I forgot to hit record for people who are trying to watch the recording, but here's the beginning. You just missed the first, 5 minutes. So y is equal to something like 2 to the x. So does anybody remember how we take the derivative of y equals 2 to the x, right? So that's one of the weird ones, and I'm trying to, let me see, if you use, I can tell you where, I'm trying to grab my calculus textbook here. So they usually show up, like when I teach calculus and I use, and I use the book by, if you had it with me, the Haas, Weir, and Thomas, which a lot of people, that is the book that a lot of people use. They do these kind of separately, and they can be found in section 2.10, but that's not the book. I'll tell you what it is in the book that I put up for us. But okay, so let's see. So 2 to the x ln of 2, right? Or ln of 2 to the x, exactly. So y prime equals 2 to the x. So it acts a lot like e to the x, but since it's not e to the x, you have to tack on that natural log of 2. And so if you have, in general, y equals a to the x, y prime is going to be a to the x natural log of a. And similarly, does anybody remember what happens if you had y equals, say, log base 5 of x? What y prime would be? I know, they're tricky, right? Or I shouldn't say, it's not that it's so much tricky, it's just that you probably didn't actually spend a bunch of time doing them in Calc 1. Even when I teach Calc 1, we don't do them a bunch. But these guys actually show up a bunch in our Calc 2. So that's why we're kind of reviewing them. 1 over x ln 5. Yep, exactly. So it acts a lot like 1 over x, right? So it's 1 over x and then natural log of 5. So you get an extra factor of that natural log down there in the bottom of the denominator. So if I have y equals log base b of x, y prime is going to be equal to 1 over x ln of b. Any questions so far? No? Okay. So what other things haven't we taken derivatives of yet, right? So we've covered a lot of stuff, right? Covered anything we can write as a power. We've covered exponentials, logarithms. What other big things have we not done? Okay, so we haven't done quotients. Yep. So we're definitely gonna do quotients. But before we do that, there's some still just basic rules we didn't do yet. Trigonometry, right? Yeah, trig functions, everybody's favorite, right? So the trig functions, right? So the rules for trig functions. If y is equal to the sine of x, anybody remember what y prime is? Yeah, cosine of x. And if y equals the cosine of x, yep, then y prime is going to be minus sine x. We have y equals tangent of x. So anybody remember what y prime is for tangent of x? Secant squared x. What about y equals the secant of x? Anybody remember that? Secant x, tangent x? Yep. And what about y equals the cosecant of x? Yep, so I like to kind of remember that everything, when you're taking the derivative, everything that has a co is the things that are negative, right? So the derivative of the cosine, so the derivative of the cosine is negative. The derivative of the cosecant is going to be negative. And then when we get to here in a second, the cotangent, that's also going to be negative. So negative cosecant x cotangent x. And then finally, if y is the cotangent of x, y prime is, minus cosecant squared of x. Right. So those are the basic trig derivatives. And that covers, I think, pretty much all of the main basic functions. So a lot of you guys were shouting out other rules, right? Like product rule, quotient rule, chain rule. So those are kind of the three big things, right? So let's write them down so we have them. So the product rule. Okay, so there are lots of ways to remember the product rule. When you went through, actually, Calc 1, depending who you had, they might have taught it different ways. So a lot of people teach it if you have y equals u times v. Then y prime is, so you might have written it one of two ways. Either u v prime plus v u prime, or you could flip-flop the order, right? You could say v u prime plus u v prime. If you had me for Calc 1, right, I tend to kind of say a lot first times the second of the derivative of the second plus the second times the derivative of the first. And if you didn't have me for Calc 1, you might have learned the order flip-flopped. So you might have learned first times the derivative of the second plus second times the see, I can't even say it that way. Second times the derivative of the first plus first times the derivative of the second, right? And so it's one of those things. I learned the product rule back in 1996. And so when I learned it in 1996, it was taught to me as first times the derivative of the second plus second times the derivative of the first. And so I've been doing it that way for, what is it, 96 to now is what? Like, it's a lot of years, right? I'm old. It's 20 some years. So for 20 some years, and I even sound even older when I say 20 some years, but for 20 some years, I have been doing the product rule that one way, right? And so it is really hard for me to do the product rule, to say it, to have the words come out of my mouth, second times the derivative first plus first times the derivative second. I have to really concentrate to say it. So if you ask me to recite the product rule, I'm going to say first times derivative second plus second times derivative first. And that's just how it's going to go. But either way is totally fine. So that was a long way of saying either way is totally fine. But I feel like sometimes in like this online environment, we kind of have to break things up a little bit, right? Especially since I'm the one talking for the entire time and it can get boring. So I got to lighten it up a little bit here, right? Okay, so that's the product rule. Quotient rule. So the quotient rule. So again, you might have written the quotient as, let me see. I don't know why. Let me make sure, because I just wrote it down on my paper or on my thing, and now it's not showing up for you guys. So let me, oh, there it goes. Let me check the, okay. So we have the quotient is u over v. And so the quotient rule tells us that y prime is equal to the bottom v times the derivative of the top minus the top u times the derivative of the bottom all over the bottom squared. And so that is this top part here has to be in this order, right? I cannot flip-flop the order. I can't put the u v prime first. So this one, it has to be in this order. So I, again, remember bottom derivative top minus top derivative bottom all over the bottom squared. And then there is, the other big one is the chain rule, okay? So if you had me for Calc 1 and I taught you the chain rule, then what I'm about to do is not going to look different to you. But if you did not have me for Calc 1, then when I teach the chain rule, like, so there is the very proper way to teach the chain rule, right? So we can say the chain rule is that you have y equals to f of g of x, right? So you have a function within a function. So remember, the chain rule is used when we have composition of two functions. And so the formal way of saying that is that it is the derivative of the outside function, keep the inside function the same, so f of g of x times g prime of x. But if you had me for Calc 1, then you know that I like the word stuff. And so really all that's happening when we have the chain rule is if I have, so basically chain rule, we'll call it via stuff. So for us, the way we see the chain rule is a couple different ways. So we might see y equals a bunch of stuff to a power. And so the derivative of that is so just like as if you want to pretend like the stuff is an x. So this stuff here is the x. So when I had x to a power, the power would come down. I'd have x to the power minus 1. So when we're talking about the chain rule, we're talking about the power comes down. We have all of our stuff to the power minus 1 times the derivative of the stuff. So you always have to multiply by the derivative of the stuff. You could also have y equals the trig function of a bunch of stuff. So you might have y equals the sine of a bunch of stuff, or y equals the cosine of a bunch of stuff, or y equals the tangent of a bunch of stuff. And in that case, y prime is going to be the derivative of the trig function. Keep the stuff the same. So the argument of the trig function is going to stay the same. And then again, we're going to multiply times the derivative of the stuff. And you could have e to a bunch of stuff. So y prime is going to be e to the stuff. Again, times the derivative of the stuff. Or if we had y equals the natural log of the stuff. Okay? We said the derivative of the natural log was 1 over x. So we don't have an x this time, we have stuff. So it's going to be 1 over the stuff times, oops, I forgot my prime there, times the derivative of the stuff. You guys can call me out on things when I write stuff wrong, right? Don't let me keep writing stuff wrong if you notice it. So that's kind of like the chain rule, the way I usually teach it. I usually teach it in terms of this stuff. Questions? You know, it looks like my video froze. Can you guys still hear me? Oh, nope, of course not.